Hi folks, David at Semper. Responding to a question received regarding what happens if you drive an LED with DC voltage instead of driving with current or amperage. Now I am wiring up a single LED to a DC power supply where I can adjust the voltage into the LED. Okay, I'm going to step it all the way down and turn it on. Okay. Now, as I step up the voltage, okay, I'm up to almost a volt, 1 volt. Okay, 1.7, you can see that it's just starting to turn on. LEDs, okay, require a certain amount of forward voltage before they even energize, before they activate. Okay, all diodes are that way. I want you to see how drastic driving an LED using a voltage source can impact an LED and why you don't drive it that way. Okay, so we're up to 1.8 volts, 2 volts, now we're up to 30 milliamps. Okay, it goes from 30 milliamps to 100 milliamps, just up to 2.2 volts. Now if we go up to 2.5 volts, which is a very minor change, I mean 2 to 2.5 volts, we're already at 260 milliamps. Now, if I go up to 2.8 volts, which is the rating of this LED, we're at 370 milliamps. So, we started out at 1.7 volts, the LED turning on. And now we're up to just 2.8, and it's already at its rating. So in the span of about 1 volt, it went from 0 up to its maximum rating. Now, if I go up to 3 volts, 450 milliamps, 3.2 volts, 530 milliamps. What I'm trying to demonstrate on this is to answer your question, is that you can't reliably drive an LED with a voltage source. Number one, every LED is going to react differently. This at 2.8 volts will reach its drive current. Maybe these LEDs here, it's obviously going to be different because there's 3 LEDs, but each one of these LEDs, it's a different type of LED and might have a different rating. They're saying it's going to turn on at 2.2 volts, this particular LED. So if you're at 1 volt, 1.5 volt, 2 volts, you're getting nothing out of the LED. Once you hit 2.2, it will start to come to life. 2.4 volts, about 80 milliamps. Get up to 3 volts, and you'll see that's about where it's rated for this LED. This is a high power LED that says down here you can see 350 milliamps. So at 350 milliamps, you'll see that it's right around 3 volts. Low power LEDs, high power LEDs, they'll behave very much alike. This curve may shift one way or the other. Okay, so maybe the LED turns on at 2 or 1.8. You're typically not going to go much below that. There aren't LEDs that turn on at 0. Okay, so this is very typical. And you'll see that it's a very narrow range, 2.2 up to 3.8. That's only 1.6 volts. So if you're attempting to drive LEDs with voltage, it's risky in some cases. And so I just wanted to show where this really takes off. So you'll see that it goes from 200 milliamps at around 2.7 volts up to 700 milliamps at 3.6. So in less than 1 volt, so if you're trying to drive it with voltage, an LED is a current-driven device, but if you're attempting to drive it with voltage, then you can see that it's almost impossible to do. Yeah, in a lab you can do it, but in the real world, out in the field, it's not a real practical solution. And that's why you want to use a constant current driver. Now for LED strips, they'll have a resistor already on there. Some products have a regulator or a driver built in, and what those devices are doing is they're ballasting the current to the LED. Now how good they are? Well, there's no way to know until they're evaluated. Unfortunately, driving anything requires a certain amount of losses. Nothing that deals with electricity is 100% efficient. And if it is not 100% efficient, it's going to generate heat. If it generates heat, well, then care needs to be taken. Go to our website, click on FAQ, Knowledge Base, send in your questions, send us emails, phone calls, let us know how we can assist in answering your questions. Okay? Have a great night. Thank you.